Hello and welcome guys in this new video. In this video, going to talk fifth question of data science in third assignment. Discuss the importance of dimensionality reduction in machine learning. Compare and contrast feature extraction and feature selection as a two approaches to dimensionality reduction with examples and their technique. Intro- Introduction to the dimensionality reduction. When working with the machine learning models, data sets with too many features can issue like slow computation and overfitting. The dimensionality reduction helps to reduce the number of features while the retaining key information. It converts the high dimensional data into a lower dimensional space while pursuing information of important details. How dimensionality reduction works. Let's understand how the dimensionality reduction is used with the help of an example. Imagine a data sets where each data point exists in a 3D space you see in the this diagram. Defined by axes of x, y, and z. If most of the data variance occurs along the x and y, then the z dimension may contribute very little to understand the structure of the data. Example table have a four columns student height, weight, and BGMI. The table explanation point wise, the data sets has three features height, weight, and BMI. BMI is not an independent feature because it is calculated from height and weight. So BMI does not add new information and become a redundant feature. Therefore, the important information exists only in two dimension height and weight. Why do we reduce? We reduce dimensions to remove the unnecessary features so that the model becomes simpler and faster without losing information and important patterns in the data. By reducing 3 to 2 feature here, we keep the core information while improving model performance. The benefit of this is faster training and lower storage. It takes less overfitting and better generalization, easier visualization and interpretation. The dimensionality reducing technique. First, feature selection. First, feature selection is a core step preparing data for machine learning where the goal is to identify and keep only the input features that contribute most to accurate predictions. By focusing on the most relevant variable feature, the selection helps to build the model and that are simple, faster, and less prone to overfitting and easier to interpret, especially when the use data sets and containing many features, some of which may be irrelevant or redundant. A filtered method. By using this method, we rank the features by static score, select the top feature, and feed into the models. Wrapping method. In the wrapping method, collecting data from the sources and select a subset of features. After this, train the model and evaluate them. And last is repeat with the different subsets. Method C tells us embedded method. Embedded method trains model with all features and going with the flow and model selects the important features to use the selected feature. Feature extracting. The second method is the process of transforming raw data into a simplified and informative sets of feature or attributes. This reduces the data complexity and highlights the most relevant information, making it easier for machine learning model to analyze and learn from the data efficiently. It plays an important role in improving model accuracy and reducing the computational cost by focusing on the essential aspect of the data. Some methods are statically method, dimensionally reduction, backward features, and elimination. Different features of selection and feature extract method is featuring. In the selection, first we show the attributes of them. Select a subset of relevant feature from the original sets. Reduce the dimensionality while keeping original features. Method including filters, wrapped embedded technique, and require domain knowledge and feature engineering. Enhance the interpretability and reduce overfitting. May lose useful information if important features are removed. In feature extraction, it transforms the original feature into a new, more informative sets and reducing the dimensionality by transforming data into a new space. The method including PCA, CDA, and kernel PCA and auto encoders can be applied to raw data without prior features engineering, improve performance, and handle non-linear relationship. May introduce redundancy and noise if extracted features are not well defined. Thank you.